This problem states among all pairs of numbers whose sum is 22, find a pair whose product is as large as possible. Also, what is the maximum product? Now, this problem has several variables in it. First of all, I have a pair of numbers. That means two numbers. So I'm going to let x equal the first number and y equal the second number. Also, I need to deal with their product, so I'm going to let p equal the product of the two numbers. Well, how do we write the product of two numbers? That's just multiplication. So p equals, I'm going to multiply the first number x by the second number y. So p equals x times y, and I need to find the maximum possible product. The problem is I have two variables on the right-hand side of this equation. I just want one. But I'm going to use this piece of information about the sum to reduce the number of variables on the right-hand side. Remember, sum means add, so I'm going to add the two numbers. So I'm going to get x plus y, and their sum equals 22. So I have x plus y equals 22. Now I can solve this equation for x in terms of y or y in terms of x, but we're much more used to writing our functions in terms of x, so I'm going to solve this equation for y. So I'm going to subtract x from both sides, and I get y equals, unlike terms on the right-hand side, can't combine 22 minus x. Now I can take this expression and put it into my equation for the product. So the product p can now be written as x times, instead of y, I'm going to get 22 minus x. So p is now written in terms of one variable x. So I can say my product function p of x equals, distribute in the x times 22 is 22x, x times negative x is negative x squared. What type of function is this? Notice the highest exponent on an x is a 2. It's a quadratic function. We like to write them in descending order, so I'm going to start with negative x squared and then have plus 22x. Now I want to compare my function to f of x equals ax squared plus bx plus c. Remember, the x-coordinate of the vertex is at negative b over 2a. If a is positive, the parabola is going to open up and look like this. If a is negative, the parabola is going to open down and look like this. So in our case, a is the coefficient of the x squared term. So a is negative 1. So it's less than 0. So I know my parabola is going to open down. And therefore the vertex, the y value of the vertex, will give me a maximum value. So this problem basically boils down to finding the coordinates of the vertex, and I'm going to use this formula here. I already know a equals negative 1. B is the coefficient of the x term, so it is 22. I'm running out of room, so I'm going to go up here. Now, to find the x value of the vertex, it's negative b divided by 2a. So it's negative b is 22 divided by 2 times a is negative 1. So that's negative 22 over negative 2, which is positive 11. So I know one of my numbers. I need to also find the other number. The other number is y. So y equals 22 minus x. So it's 22 minus 11. 22 minus 11 is 11. So there are my two numbers. I need to find the maximum product. That is the value of the product function p when x equals 11. Plug 11 into this equation. I get negative 11 squared plus 22. Sorry, I'm running out of room here, times 11. So 11 squared is 121, so it's negative 121 plus 22 times 11 is 242, and negative 121 plus 242 is 121. So this is the maximum product. So writing out my answers, I know the pair of numbers are x and y, so they're 11 and 11, and the maximum product is 121. We can double check. If I multiply my two numbers 11 and 11, do I get 121? Yes. And if I add my two numbers 11 and 11, do I get the sum of 22? Yes. That's a good final check for this problem.